In this video, I'll be checking my PI data archive for a lot of common problems that it might be having with its archiving functions. Archiving is a very important part of the PI system, and maintaining its health and detecting problems are critical roles of a PI administrator. If archiving isn't working properly, interfaces may be unable to write data, data could be inaccessible to clients, or you could be losing data or suffering from poor performance. Here in PI System Management Tools, the first thing to check to ensure archiving health is here in Operation PI Services. I'm checking to make sure that the archive subsystem is running. If it's not running, it may have crashed, or it was stopped, or didn't start properly. If it wasn't already running, I could right-click here and attempt to start it. Now if I tried to start it and it's still unable to start, I may have a corrupt or missing primary archive, or there could be problems with the service or the machine resources. The next check to do regarding archive health is in the Archives menu. If your archive subsystem isn't running, this page doesn't load any archives, and there will be an error printed down here in the session record when we open the screen. Here, if we're running PI System Management Tools 2015 or later, we can see that my archive drive has lots of free space. If you're running a version of PI System Management Tools before 2015, the archive disk space won't be displayed here, so we'll have to use Windows Explorer. And here we can also see that my archive drive has lots of free space. The next check is to make sure that I have a primary archive that isn't full. This archives are primary, and I can tell because it has a fixed start time with an end time of current time. And I can see here that it still has room in it. Another problem we might see here is an archive gap. I don't have any archive gaps, and we can see that each archive's end time is right up against the next archive's start time. But if you do have an archive gap, or a space between two archive files, a line in System Management Tools will show you that you have an archive gap, and it will show information about when that archive gap starts, stops, and its total length. This is important because any data sent to a time period without an available registered archive will be lost. Also, any data sent to a time period before the first archive will also be lost. So if I was expecting to receive any data before my first archive starts, I would need to create some new older archives. The next checks are in the Snapshot and Archiving Statistics menu. I'll start by looking at my archive statistics, so I'll choose to only show those statistics by filtering here. Here, my archiving flag is 3. Before version 3.4.375, or PI Data Archive 2015, 0 meant archiving was turned off, and 1 meant archiving was turned on. As of version 3.4.395, the PI Data Archive supports future data, so the archiving flag can also show a value of 2 to say that future data archiving is on, or 3 to show that future data archiving is on and historical archiving is on. Check for the version information here if you're not sure about your system. If your archiving flag is 0 or 2, you may be having problems with your primary archive's integrity, or you could be having problems with the archiving service that we already checked, or you may have a failed archive shift that you haven't recovered from yet. If you do have a failed archive shift, this flag shows a 1. Mine's a 0, so we know that my last archive shift was a success. My archive loaded flag is also 1 to show that I have a primary archive loaded into the archive subsystem. The last thing on this page is in the archived events counter. If archiving is enabled, and we have data being sent to our PI data archive, this number should be increasing when I hit refresh. If you want reference material for any of these statistics, you can find their sections in our PI Server 2015 guide, or by searching for them in our PI Live library. Next up is the Snapshot statistics. Filtering by snapshot, we can see events sent to queue and events in queue. Data gets sent and goes through the event queue before it reaches the archive files. So if events in queue is low and not growing, but events sent to queue is growing, that means the data is likely flowing through our event queue into the archive files. If your event queue has corruption in it, or your PI.archive's archiving flag is turned off for one of the reasons we already discussed, data could be stuck in your queue, and events in the queue will likely grow until the problem is solved. We've confirmed archiving is already working, so a buildup in events here would likely indicate corruption in the event queue. My number of queue files is 2, and a healthy number of event queue files will be 1 if your PI.archive doesn't support future data, but it'll be 2 if your PI.archive does support future data. If you have more than this amount, there's likely unarchived events sitting in excessive amounts of queue files. More information about these statistics is also searchable in our live library. If you've checked these things and are still unable to read or write to particular archives, it's possible that you have corruption in one or more of your archive files. Here in the message log, we could get errors and warnings that would indicate archive file corruption. For example, I do have a piarchss message informing me of a failed user query. Now scrolling to the rest of the message, I can see that it's due to a record header version mismatch. Messages like this are indicative of archive file corruption. Other messages that indicate archive file corruption also include, but aren't limited to, these in KB 2367. If we do suspect an archive of being corrupt, we can analyze it for errors by running a diagnostic tool from the command prompt. Let's say that writing to this archive, we get one of the errors from KB 2367. To check for corruption, we first have to unregister it, keeping in mind that this will create an archive gap. And now we can open a command prompt as administrator and navigate to our %piserver%/adm environment variable using the D flag. We'll use the program pidiag and the option archk for archive check. And then we'll type in the file path to the archive file that I just unregistered and want to check for corruption. I'll send the output to a text file on my D drive so I can analyze it. While this is running, this will print all the results of the archive check to the text file I specified. So when I navigate to the D drive and open that file, we'll see the results of the archive check. If the archive check is complete, we'll see this summary at the bottom, and we can tell that there are 0 errors with 0 warnings, so the consistency check will report a success, indicating that there's no problems with this archive. Once we know it's healthy, it's important to register it again to make sure we keep archive gaps to a minimum. Back on my D drive, I have an archive to use as an example of a corrupt archive. So back in the command prompt, I'll run the same pidiag archk command, but this time d piserver2_example, and send it to a different text file. This is going to print all the messages to the text file I specified again. Once the archive check is complete, we can go into the text file we created to see all of the error messages that an archive check produces. And at the bottom, we can see how many error messages there are and the overall health status of our archive file. Some events that used to be in this archive file may be lost, but it's possible to turn this into a healthy archive file again through a procedure called reprocessing. So far in this video, we confirmed that our PI.archive is successfully archiving data by inspecting the most common places where we would run into archive problems. In the next video, I'll be reprocessing archives to clear corruption, but also to merge archive files or to split larger archives into different time periods or smaller file sizes.